Alrighty, in this video we will graph piecewise functions. On the previous one we did evaluate piecewise functions, but I did want to add one more question. I may ask you to find something like this on your daily problem or on your exam. Find f of negative 5 minus f of negative 3 plus 2 times f of 7. What if I ask you something like that? Well, it's nothing more than just putting together what we already found in this case. F of negative 5, remember we found that to be positive 2, right? So f of negative 5 is 2. And copy down the minus sign. And what is f of negative 3? F of negative 3 is negative 2. So I have to do 2 minus negative 2. And then plus 2 times what's f of 7? F of 7 is 2 times 2. So this just turns into 2 plus 2 plus 4. Therefore, the answer is 8. So if I ever ask you for something like this, like a sum or difference of different pieces, that's all you need to do. Just find each pieces and combine them by either adding or subtracting. Sometimes you have to multiply by something, but I do want you to try something like this for your daily problem. And the key is just get the pieces right first, and then you combine it. You put them together. So submit something for me. I will take a look and see how you are doing. But let's go and graph some piecewise functions in this video. All right. Suppose that the function f is defined for all real numbers as follows. I have 2 pieces, so what I'm going to do is I'm going to graph 2 pieces using 2 different color pencils, okay? So the top piece, it says if x is less than 4, but what I will start with is I will plot the 4, but with just an open circle. I'm going to plot an open circle at 4 something because it says if x is less than 4. If it said x is less than or equal to 4, then I would plot a closed circle. But because it says x is less than 4, make sure to plot an open circle at x equals 4. All right, if I plug in, because remember the function is half x minus 1. If I plug in 4 into this, let's see what we get. Half of 4 is 2. 2 minus 1 is 1. So we're going to plot an open circle at 4, 1. Let's do that. 4 to the right, up 1. Open circle right here. And I need a couple more. I mean, the minimum is 2, because in order to draw a straight line, we just need 2 points. But I think I'm going to do more than 2, maybe like 3 to be safe. I need a number that is smaller than 4. Why? Because it says x is less than 4. So what is a good number that is smaller than 4? I'm thinking 3. But since the function is telling us to take half of a number, 3 is an odd number and half of an odd number is a decimal. So I'll try to go with even numbers. 2 is a small number, right? And 0, that should do it, right? Or maybe negative 2. The more points you have, the more accurate your graph will be. But we need to make sure that all the x values that we picked are smaller than 4 because it says use that top piece only if x is smaller than 4. So I'll go ahead and find a couple points here. Plug in the 2 into the function. Half of 2 is 1. 1 minus 1 is 0. I will plot a regular point at 2, 0. 2 to the right on the x-axis. Or if I plug in 0, half of 0 is 0. And 0 minus 1 is negative 1. So I'll plot a point at 0, negative 1, 0, negative 1. And last one, half of negative 2 minus 1. That is negative 1 minus 1, negative 2. I'll plot a point at negative 2, negative 2. Negative 2, negative 2. And your points should be on a straight line. You should see a pattern. And I can go ahead and graph a straight line that is going down to the left. And that does look like y equals half x minus 1. But I should not extend it to the right side of it. No, because it says use it only if x is less than 4. That's why this green piece of graph is only going to the left side of x equals 4. All right, I am halfway done, right? I'm halfway done. Let me minimize this one a little bit. Oh, whoopsies. Because now I am about to find or graph the second piece. I'll stick it right here. All right, the second piece, let me use a red pen. All right, I'm using this bottom piece if x is greater than or equal to 4. So, x and y table, okay? If x is 4, well, remember what kind of circle I want to draw for these greater than or equal to. I will plot a closed circle over here. If I plug in 4 into the bottom function, which is negative x plus 5, I will get negative 4 plus 5. And that's 1. So let me plot a point or closed circle at 4, 1. 4 to the right, up 1. Oh my goodness, look. I had an open circle right there, but now I just closed it. Oh, that's good. But that's not always going to happen. I just, my closed circle happened to fit right into that open circle. But now let's keep, and we need more points than just one. Let's go ahead and graph this red line. I need to pick x values that are bigger than or equal to negative 4. So 4 is fine. I'll do 5, 6, and 7. Okay? If I plug in 5 into the function, that will be negative 5 plus 5. And that's 0. Let's plot 5, 0. 5 to the right, 0. If I plug in 6 into the function, that is negative 6 plus 5, negative 1. Plot 6, negative 1. 6 to the right, down 1. And I can see the pattern is going down 1 over 1 to the right as the slope of this linear function is negative 1. But I can find it. Negative 7 plus 5 is negative 2, which means I will plot a point at 7, negative 2. 7 to the right, down 2. And if I connect these dots, this is going to be going down to the right. And we did graph our first piecewise function. In calculus class, you will talk more about continuity. But if you look at this graph, and if I ask you a question, can you graph this function without lifting your pencil? Look, I can graph this piece, and because they met right there, I can just continue going down. And without lifting my pencil, I can graph this function. So the last question is asking is this function continuous? And your answer is yes. Okay? You do more, because I'm teaching 261 this semester. We do talk about continuity with a little more formal definition and more examples. But in our class for right now, if you can graph this function without lifting your pencil, we're going to say this function is continuous. All right, let's do the last one. I'm wondering if I can make, probably, all right, I'll just fix this later. All right, suppose that the function h is defined. Typo right here, change this guy's name to h for me. Let's call this guy h. For all real numbers as follows. The first piece, I'll do one at a time. It says use the y value of 6 if x is less than negative 4. So if I do my xy table, it's going to be a boring one. I will have an open circle at negative 4. But the y value is just going to be 6. It's a constant function. So open circle at negative 4, 6. They said less than negative 4, so I need to go smaller. Negative 5, negative 6. All these smaller numbers, they will all have a y value of 6. Just because it said 6. It's a constant function. So let's go ahead and plot some points at these values. Yeah, that's the first piece. So 4 to the left, up 6. I'm going to plot an open circle. And then 5 to the left, up 6. 6 to the left, up 6. And I can see the pattern is just keep on going to the left. A horizontal line, okay, a graph of a constant function, to the left of x equals negative 4. All right, let's do something a little more challenging, or maybe something like this. Okay, when are we using this? We're using this middle piece for x values that are in between negative 4 and positive 4. I don't have to graph all of them, but I'm definitely going to plot negative 4 with what kind of circle? Closed circle, right? And I need some numbers in between. I don't think we need to do all of them, so I may just skip around and do negative 4, 0 and maybe, I don't know. We can do more than, I'll just do 4. But 4 will have a open circle. Why? Because it says x is less than 4, not less than or equal to 4. So if I plug in these hand-picked x values into the function, I will get negative 10 plus negative 4 squared, which is negative 10 plus 16, 6. So let me put an closed circle at negative 4, 6. Plugging in 0 will give me this, and that's going to be just negative 10. So plot a point at 0, negative 10. And lastly, if I plug in positive 4, I'll get negative 10 plus 16. So we're back up to 6. So I'll plot an open circle at 4, 6. All right, let's plot those 3 points. So 4 to the left, up 6. Oh my goodness, look at that. That's where we used to have that open circle, but now we're going to close it. So it's going to be continuous from the far left piece to the middle piece. And 0, negative 10. And, you know, if you want to plot a couple more points in between, that is fine. But we know it's a parabola, so it's going to go down like that. And we're going to have another point at 4 to the right, up 6. But remember, this one is an open circle. Okay, so let me try to draw a parabola. Wow, that's ugly. Or something like this. See, that's why I want to do more than just 3 points, but, you know, we know what x squared minus 10 looks like. It's a parabola shifted down 10 units. All right, let's do the very last piece. I'm going to do that in green color. 2x minus 1, and we're going to use that if x is greater than or equal to 4. All right, so xy table right here. I will plot 4 with the closed circle. And they say greater than or equal to 4. So all the x values that I'm picking are going to be bigger than 4. 3 is enough. So if I plug in 4, I will get 2 times 4 minus 1, which is 7. Let me plot 4, 7. I'll do the plotting later. And just find the rest of these. 10 minus 1 is 9. And if I plug in 6 for the last one, I will get 12 minus 1, 11. I won't be able to graph that one. All right, but closed circle at 4, 7. 4 to the right, up 7. Oh my goodness. They're sitting on top of each other, but they're not completely, my filled-in circle, my closed circle did not fill in that open circle. So, you know what? This function is not going to be continuous. Next one, 5, 9. 5 to the right, up 9. And the last one that I have is 6 to the right, up 11. I'm out of the graph, but that's enough. I have my third piece going straight up from that closed circle. And it was continuous. Like, you see how when I'm, if I follow this graph, I'm continuous all the way to this point, but then I have to jump. At this spot, I have to, whoopsie. It was all continuous over there, but I need to jump and come back up to this green filled-in circle and go up that way. So because of this area right there, this function is not continuous. Not continuous. And we can go ahead and say that we have a point of discontinuity at x equals 4. But for right now, we're just going to answer yes or no questions based on the fact, can we graph this function without lifting our pencil? If the answer is no, then this is not continuous. Now that's it for graphing, but you're going to see so many different, piecewise graphing functions on your Alex homework this week. So if you're having issue with a couple of them, just send me a picture of it, send me a screenshot of it. I should be able to help you graphing it, okay?